You've never once felt yourself move through the universe. You can sit perfectly still in your chair, convinced that you are completely at rest, securely anchored to solid ground. But your senses are deceiving you on a massive scale. Right now, you're being hurled through the cosmos at a terrifying speed, plunging headfirst into a vast unseen ocean of ancient light. There is a hidden, glowing boundary wrapped around our entire galaxy, an invisible wall of radiation left over from the dawn of time. And you are crashing against it, pushing through the oldest heat in existence without even feeling a breeze. You might think you're sitting quietly at home, but in reality you're speeding relentlessly against the outer edge of everything we can ever know. Every time you stare up into the empty darkness, you naturally assume you're seeing the universe exactly as it exists today. You picture distant stars burning in real time, galaxies swirling in the present moment, and a vast open void stretching out infinitely in every direction. But modern astrophysics tells a much more unsettling story. The truth is, our entire solar system is trapped inside an inescapable sphere of time, surrounded by a blinding wall of primordial radiation that limits everything we can perceive. There is a definitive optical boundary to our reality. Today you'll find out what the edge of the universe really is, and why looking past it is physically impossible. If you love wandering through the night sky, subscribe to the channel. That's what keeps this work going. Before we set off, one question for you. Where in the world are you watching the sky from, and what time is it where you are? Tell us in the comments. Let's step into the ancient light. To understand how we finally hit the ultimate optical boundary of our reality, we first have to look at the fierce intellectual war that tore astrophysics apart in the 20th century. It is a story of brilliant predictions, ignored evidence, and monumental egos clashing in the dark. If you were to walk into any major astronomical observatory in the early decades of the 1900s, you could ask the leading scientist about the history of the cosmos. They would have given you a very confident, very comforting answer. They believed that they had already figured out the grand architecture of reality. The reigning dogma was that the universe was eternal, static, and fundamentally unchanging. For centuries, the human mind had found solace in the idea of a permanent heavens. Even when astronomical observations eventually proved that galaxies were drifting apart, brilliant and influential minds like Fred Hoyle fiercely defended the established order. Hoyle championed what was known as the steady-state theory. In this deeply philosophical view, the cosmos had no violent beginning and would suffer no chaotic end. As space expanded and galaxies moved away from each other, new matter simply popped into existence out of the void to fill the growing gaps, keeping the overall density and appearance of the universe perfectly constant. It was an elegant, peaceful vision of a universe that had always been there and always would be. For decades, the scientific establishment felt a profound sense of satisfaction. They were absolutely convinced that the biggest question of all had been definitively solved. There was no origin story to uncover, no fiery genesis to look for, just an endless, majestic continuity that stretched infinitely backward and forward in time. But a few rebellious physicists began to chip away at this comforting illusion, setting the stage for a bitter scientific conflict. George Gamow, a brilliant, loud, and eccentric theoretical physicist, argued that the universe did not stretch back into infinite tranquility, but rather began in a state of unimaginable density and heat. If you ran the cosmic clock backward, Gamow insisted, all the matter and energy in existence would compress into a single, blindingly hot primordial soup. He mocked the steady-state theory as a mathematical fantasy, and in return, the establishment mocked him as an undisciplined dreamer. The battle lines were drawn, and the scientific community was forced to choose sides in a war that would determine the fundamental nature of reality itself. In 1948, two young and ambitious researchers working with Gamow, Ralph Alpher and Robert Herman, decide to take this radical idea and push it to its absolute mathematical limits. They sit down in their offices with nothing but pencils, paper, and incredibly complex thermodynamic equations. They realize that if the universe really did start in a fiery explosion, that initial heat couldn't have just vanished into nothingness. The laws of physics dictate that the energy must have expanded, cooled, and stretched over billions of years as space itself grew larger. Alpha and Hermann make a stunning, unprecedented prediction. They declare that the ghost of that ancient fire must still be out there right now, bathing the entire cosmos in a faint, freezing glow of roughly 5 Kelvin. It is 1948. The young physicists publish their groundbreaking paper, laying out the exact blueprint of the universe's oldest light. They have just handed humanity the map to the edge of the universe. They expect the scientific community to be thrilled, to race to their telescopes and begin the hunt. They wait for the world to notice. But instead, they are met with deafening silence. The technology of the time is considered too primitive to detect such a weak signal, and the established dogma of the steady state is simply too strong to challenge. Their brilliant prediction is dismissed, buried in the dusty archives of academic journals, and entirely forgotten by the very people who should have championed it. Yet, while the theorists were fighting over mathematical equations in crowded lecture halls, the physical evidence was already bleeding into our world, completely unnoticed. And you have to imagine the sheer irony of the situation. The universe was whispering its deepest secret, but no one on Earth knew how to listen. Back in 1941, 7 full years before Alpha and Hermann even published their paper, an astronomer named Andrew McKellar was quietly working at the Dominion Astrophysical Observatory. He was studying the faint optical signatures of cyanogen molecules drifting in the freezing empty spaces between the stars. Through his precise spectroscopic measurements, McKellar noticed something incredibly strange in his data. The molecules were being excited by a mysterious ubiquitous background heat, a temperature of about 2.3 Kelvin. This was, without a doubt, the first indirect detection of the universe's oldest light, the very edge of time itself manifesting in a scientific instrument. But nobody makes the connection. The monumental significance of McKellar's discovery slips right through the cracks of history, treated as a mere curiosity rather than the smoking gun of creation. The tragic comedy of missed opportunities does not stop there. In 1955, at the Nancy Radio Observatory in France, a meticulous researcher named Émile Leroux points a 33-centimeter wavelength scanning antenna at the sky. So, he detects a uniform isotropic background radiation of roughly 3 Kelvin. It is a clear, undeniable signal coming from the deep cosmos, a direct message from the primordial fire. But again, the theoretical framework is missing. The European discovery fails to ignite the revolution, and the data is simply archived. 2 years later, the curtain rises on another continent. It is 1957 at the Pulkovo Observatory in the Soviet Union. Tigran Shmaoknov is conducting exhaustive research for his doctoral thesis. He builds a specialized horn antenna tuned to a wavelength of 3.2 centimeters and meticulously scans the heavens. So, he discovers a constant homogeneous radio emission of exactly 4 Kelvin coming from every possible direction in the sky, completely independent of the time of day, the season, or the orientation of his instrument. If you had been there to see it, you would realize that Shmaoknov was quite literally staring at the glowing embers of the Big Bang. He carefully documents his findings and publishes them in a respected journal, but Soviet papers are largely ignored by Western scientists during the height of the Cold War. Furthermore, the cosmologists who could have understood the true meaning of the data are completely disconnected from the radio engineers who are actually collecting it. As a result, this massive Russian contribution is also swallowed by obscurity. For decades, the greatest minds on the planet were completely surrounded by the very evidence they claimed didn't exist. They had the math, they had the measurements, and they had the physical signals raining down on their antennas every single day. The edge of the universe was practically screaming at them from the void, and this is exactly where the logic falls apart. That massive historical failure only makes sense once you understand the pure accident that changed everything. It is 1964, and the setting is not a grand, prestigious academic observatory, but a commercial research facility in New Jersey owned by Bell Laboratories. Arno Penzias and Robert Wilson are standing in the shadow of a truly bizarre piece of engineering. It is the Holmdel antenna. If you were to walk up to it, you would see a gigantic 20-foot-long structure that looks exactly like an oversized ear trumpet or a massive angular metallic scoop pointed toward the heavens. It weighs incredibly heavy and towers over the landscape like an industrial monument. It was originally built for the Echo satellite project, designed to bounce early communication signals off large metallic balloons in orbit. But as commercial satellite technology evolved, the horn became obsolete, and Penzias and Wilson retrofitted it for radio astronomy. To ensure they get the absolute cleanest possible signal from the depths of space, they have installed a specialized Dickey radiometer at the base of the horn. This is a highly sensitive piece of equipment that is actively cooled down to a freezing 4.2 Kelvin using liquid helium. The entire setup is incredibly precise, engineered to eliminate any internal thermal noise that might interfere with their delicate measurements. They are perfectly equipped to map the faint radio waves naturally emitted by the Milky Way galaxy. But almost immediately there is a problem. A very persistent, very annoying problem. No matter where they point that giant metallic scoop in the sky, their instruments register a constant, steady hum. It is a microwave hiss with an equivalent temperature of roughly 3.5 Kelvin. It never spikes, it never dips, and it never goes away. It is just a relentless wall of noise. You have to put yourself in their shoes to understand the sheer absurdity of the moment. Penzias and Wilson are methodical, highly practical engineers. They do not think they have found the edge of the universe. They do not think they have uncovered the secrets of creation. They just think their extremely expensive antenna is broken. They spend months trying to track down the source of this irritating interference, tearing apart their circuits and questioning their own competence. First, they point the massive horn toward the bustling skyline of New York City, naturally assuming it might be urban radio pollution or radar interference bleeding into their sensitive instruments. But the hiss remains completely unchanged. They pointed away from the galactic plane of the Milky Way, fully expecting the background noise of our own galaxy to drop to zero. It doesn't. They check and recheck their complex liquid helium cooling systems. Everything is functioning flawlessly. Eventually, out of sheer desperation and a lack of better ideas, they climb up a ladder and physically crawl into the throat of the giant metallic antenna itself. There, they find that a pair of pigeons has nested inside the sensitive cone. The birds have covered the delicate reflective surfaces with a sticky white layer of droppings, which the two scientists politely document in their official research logs as a white dielectric material. Convinced they have finally found the ridiculous earthly culprit for their cosmic noise, they trap the pigeons, meticulously scrub the entire antenna clean by hand, and recalibrate the massive system from scratch. They run the experiment again, exhausted but hopeful. Well, the hiss is still there. It is coming from everywhere all at once, day and night, spring and autumn, completely regardless of the Earth's rotation or its orbit around the Sun. They are completely baffled, trapped by a signal they cannot escape. While Penzias and Wilson are fighting a losing battle against bird droppings and inexplicable static, a completely different scene is unfolding just 30 miles down the road at Princeton University. There, a brilliant theoretical physicist named Robert Dicke and his young colleague Jim Peebles have independently rediscovered the forgotten equations of Alpha and Hermann. Dicke and Peebles know exactly what they are looking for. They have done the math, and they know that if the Big Bang actually happened, the universe must be filled with a faint, omnipresent microwave glow left over from the initial fireball. To prove it, the Princeton team is actively building a small, custom-made 1-foot horn antenna on the roof of their physics building, specifically designed to catch this ancient light. They are literally putting the finishing touches on the instrument that will make history. Then the telephone rings in Dickey's office. It is Arno Penzias. Completely unaware of the Princeton project, Penzias has heard through a mutual friend that Dickey is an expert on microwave radiometry. He's calling to ask for technical advice on how to fix this annoying, inescapable 3.5 Kelvin noise in the Bell Labs antenna. As Dickey listens to Penzias describe the isotropic, constant static that comes from every direction in the sky, the realization hits him like a physical blow. The Bell Labs engineers have already found it. He slowly hangs up the receiver. He turns to his colleagues in the laboratory, the men who had spent years calculating the physics of the early universe, and delivers one of the most famous lines in the history of science. He simply says that they have been scooped. With that single, heartbreaking phone call, the cosmic puzzle pieces finally lock into place. The irritating static that Penn, Zeiss and Wilson were desperately trying to scrub away was, in fact, the blinding flash of the Big Bang, stretched and cooled by billions of years of cosmic expansion. The Bell Labs team had accidentally tripped over the very edge of time while trying to calibrate a commercial radio dish. The two groups published their historic papers side by side in the same scientific journal. The Princeton team provides the brilliant theoretical framework, explaining exactly what the signal means and how it definitively proves a fiery origin to the cosmos. Penn, Zeiss and Wilson provide the flawless, undeniable measurement of the radiation itself. Yet, when the Nobel Prize in Physics is awarded in 1978, the incredibly prestigious honor goes entirely to Penn, Zeiss and Wilson. The Princeton theorists who actually understood the profound thermodynamics of the universe and laid the essential intellectual groundwork are completely ignored by the Nobel Committee. It remains one of the most bitterly debated injustices in the modern history of astrophysics, a stark reminder that in science, finding the answer is sometimes rewarded far more than understanding the question. But regardless of who received the gold medal, the scientific impact was immediate, explosive, and utterly devastating to the old world order. The moment that microwave signal was independently confirmed, the eternal, unchanging universe was officially dead. The steady-state theory collapsed overnight. Fred Hoyle's comforting vision of a static, peaceful cosmos was violently replaced by a universe that was born in fire. It was a universe with a definite, explosive beginning, and it left a physical, glowing fossil of its own violent creation burning in the night sky. We had finally found the boundary. We had finally mapped the primordial fog. The mystery of our cosmic origins seemed to be perfectly solved, neatly wrapped up in a beautiful narrative of scientific discovery. But the confirmation raised an even more troubling puzzle. If you look closely at that ancient wall of light, you quickly realize that its flawless perfection completely breaks the most fundamental rules of physics. We had solved one existential crisis, only to accidentally rip open another. So what exactly is this ancient wall of light that Penn, Zeiss and Wilson crashed into? To answer that, we have to mentally rewind the cosmic clock and travel all the way back to the absolute beginning of everything. If you want to understand it, you have to forget what the universe looks like today. You must erase the cold, empty void, erase the spinning galaxies, and completely erase the stars from your mind. For the first 380,000 years of its existence, the universe was a profoundly alien place. It was not a dark, silent expanse of nothingness. It was a terrifyingly violent, hyperdense and unimaginably hot soup of raw energy and subatomic particles. It was a universe where light itself was entirely trapped. During those earliest days, the overall temperature of the cosmos was so incredibly high that atoms simply could not form. Protons and electrons, the basic building blocks of matter, were moving with such extreme thermal energy that they completely refused to bond together. Instead, they existed as a chaotic, swirling plasma. This primordial plasma was so dense and so highly electrically charged that the entire universe was essentially an opaque, glowing fog. Now, you might naturally think that because the universe was glowing, it would be blindingly bright to look at. But if you were somehow standing in the middle of it, you wouldn't be able to see anything at all. The reason has to do with how light physically travels through space. Light is carried by tiny packets of energy called photons. In a normal, transparent universe, a photon can travel for billions of light years in a perfectly straight line without ever hitting anything. But in that early primordial plasma, the cosmos was packed solid with free-roaming electrons. Every single time a photon tried to move even a fraction of a millimeter, it would immediately crash into an electron, scatter in a completely different direction, and immediately crash into another one. Think of it like a high-speed metallic pinball violently bouncing around inside an impossibly dense machine packed with billions of bumpers. No matter how much forward energy the pinball has, it can never actually travel from one end of the machine to the other in a straight line. It just continuously ricochets off the bumpers in a frantic, localized frenzy, trapped in a chaotic cage of its own collisions. That is exactly what the ancient photons were doing. They were ricocheting off the free electrons, trapped in an endless, blinding cycle of absorption and emission. Because the light could never travel forward, the universe was physically impenetrable. It was a universe completely without lines of sight. A universe composed entirely of a glowing, suffocating wall of white-hot fog that stretched endlessly in every conceivable direction. It was an environment of absolute physical claustrophobia on a cosmic scale. But the universe was not static. It was expanding at a truly staggering rate, driven by the sheer momentum of its fiery creation. And in the fundamental laws of physics, when a gas or a plasma expands, it must invariably cool down. As the dimensional fabric of space stretched larger and larger, the overall temperature of the chaotic cosmic soup began to steadily drop. Finally, about 380,000 years after the initial expansion began, the temperature fell to a critical, universe-altering threshold of approximately 3,000 Kelvin. This was the magic number. At this specific temperature, the frantic thermal energy of the particles was no longer strong enough to overcome the fundamental electromagnetic attraction between them. Suddenly, the fast-moving protons were finally able to capture the free-roaming electrons. They locked together in a massive universe-wide chemical reaction to form the very first stable, neutral atoms of hydrogen and a smaller amount of helium. In astrophysics, this monumental reality-shifting event is known as recombination. It is the exact moment when organized matter finally crystallized out of the formless chaos. But the most dramatic and consequential effect of recombination wasn't just the creation of the first atoms, it was what happened to the light. The exact moment all those free electrons were locked away inside stable atomic shells, the cosmic pinball machine suddenly lost all its bumpers. The photons no longer had anything to crash into. In a single majestic cosmic instant, the dense, suffocating fog completely cleared. The light was suddenly released, allowed to fly through the void in a straight line for the very first time in history. This sudden, glorious liberation of light is scientifically called photon decoupling. The universe instantly transitioned from an opaque wall of glowing plasma into the vast, beautifully transparent void we know today. The light that was unleashed during the great event of photon decoupling was incredibly intense, carrying the immense thermal energy of the early universe. If human eyes had existed to see it in that exact moment, the entire sky, in absolutely every direction you could possibly look, would have glowed with a blinding, brilliant orange-red hue. It would have looked as though you were standing completely surrounded by the blazing surface of a star. But that dramatic liberation of light happened 13.8 billion years ago. So why don't we see a glowing red sky when we look up tonight? Why is the space between the stars pitch black to our naked eyes? And why did Penzias and Wilson detect an invisible, freezing microwave hiss instead of a blinding optical glare? The answer lies in the relentless, ongoing expansion of space itself. You have to remember that the photons were not just traveling through a static empty box. As those first liberated packets of light began their epic journey across the cosmos, the very fabric of the space they were traveling through continued to stretch and expand. And as the fabric of space stretches, it physically stretches the light waves that are traveling through it, pulling them like a cosmic rubber band. Over the course of billions of years, the short, tight, highly energetic wavelengths of that original orange-red light were physically pulled apart by the expanding universe. They were stretched longer and longer, gradually shifting down through the invisible infrared spectrum until they were finally stretched all the way into the microwave spectrum. Simultaneously, the sheer energy of the photons plummeted in direct proportion to their stretching. The original blistering heat of 3,000 Kelvin was stretched, diluted, and dispersed over a massive volume of growing space. Eventually it became the freezing, incredibly faint whisper of just 2.7 Kelvin that our modern radio telescopes detect today. The cosmic microwave background is literally the stretched-out frozen fossil of the first light ever released. It is the definitive optical boundary of our universe, the glowing wall of the original primordial plasma stretched across the unimaginable depths of eternity. But this perfectly logical physical mechanism hides a massive contradiction. When you carefully map the exact temperature of that ancient light across the entire sky, you uncover a devastating mathematical paradox. That mathematical paradox only makes sense once you understand a terrifying truth about the cosmos. Absolute perfection is the ultimate enemy of existence. When astrophysicists first began to study the cosmic microwave background in precise detail, they found exactly what Alpha and Herman had predicted decades earlier. The ancient radiation was out there, and it possessed an incredibly uniform temperature of roughly 2.7 Kelvin. It didn't matter if they pointed their instruments toward the northern hemisphere, the southern hemisphere, or directly into the galactic plane. The temperature of the primordial fire was exactly the same in absolutely every single direction. It was a perfectly smooth, perfectly balanced, and flawlessly distributed ocean of ancient light. But rather than celebrating this flawless measurement, cosmologists panicked. The sheer perfection of the microwave background was a complete disaster for the theory of our own existence. You have to look at the universe we actually live in today to grasp the problem. When you look through a telescope, you do not see a perfectly smooth, uniform distribution of matter. You see a wildly chaotic, incredibly clumpy universe. You see massive galaxies containing hundreds of billions of stars clustering together into enormous superclusters. You see vast, empty voids stretching for hundreds of millions of light years where almost nothing exists at all. Our modern universe is defined by extreme structural differences, but gravity, the fundamental force responsible for building all of these massive structures, requires an initial imbalance to start working. If the early universe was genuinely a perfectly smooth, perfectly uniform plasma with absolutely no variations in density, then gravity would have pulled equally in all directions at once. The forces would have perfectly cancelled each other out in a cosmic stalemate. No matter would have ever clumped together. No stars would have ever ignited, no galaxies would have ever formed, and absolutely no rocky planets like Earth could have ever existed. If the cosmic microwave background was truly perfect, then human beings should not be here to measure it. The fact that you are sitting here, breathing and watching this, meant that there had to be a flaw in the primordial fire. For decades, the search for that life-giving flaw consumed the scientific community. Well, they knew that there had to be microscopic irregularities hidden within the blinding glare of the Big Bang, tiny variations in temperature and density that would eventually serve as the gravitational seeds for everything we know. To find them, engineers had to push their technology to the absolute limits of human capability, building instruments capable of measuring temperature differences of just 1 part in 100,000. When the data finally came back from orbit, the collective sigh of relief from the astrophysical community was palpable. The cosmic microwave background was not perfectly smooth after all. When mapped with extreme precision, the seemingly uniform wall of light resolved into a sprawling, incredibly complex tapestry of microscopic red and blue spots. The red spots represented areas that were infinitesimally hotter and slightly less dense, while the blue spots represented areas that were infinitesimally colder and slightly more dense. In the technical language of astrophysics, these crucial temperature variations are called anisotropies. Those tiny, barely detectable blue spots were the very first gravitational anchors. Because they were just a fraction of a percent more dense than the surrounding plasma, they had a slightly stronger gravitational pull. Over the course of the next 13 billion years, they would steadily drag in more and more surrounding matter, eventually collapsing to form the majestic, swirling galaxies that populate our night sky today. But discovering the anisotropies immediately raised another deeply profound question. Where did those microscopic variations come from in the first place? What powerful mechanism was capable of creating such intricate web-like patterns of density across the entire span of the early universe? The answer lies in the intense, chaotic physics of the primordial plasma itself, and it involves a phenomenon you experience every single day on Earth. The early universe was essentially ringing like a giant cosmic bell. Inside the hyper-dense, superheated plasma of the first 380,000 years, an epic, unrelenting battle was constantly raging between two opposing physical forces. On one side, you had the relentless pull of gravity, desperately trying to drag the raw matter inward, attempting to crush it into highly dense, localized pockets. On the exact opposite side, you had the intense radiation pressure of the trapped photons, behaving like an explosive spring, pushing the matter violently outward whenever it became too compressed. This continuous, relentless, and violent tug-of-war between gravity and light created colossal pressure waves that rippled through the primordial soup at staggering speeds, traveling at over half the speed of light. These weren't just abstract mathematical concepts on a chalkboard, they were quite literally massive sound waves vibrating through the dense medium of the early universe. Scientists call these primordial sound waves baryon acoustic oscillations. The entire universe was filled with a deep, resonating hum, a chaotic symphony of acoustic energy actively shaping the physical distribution of reality. To visualize exactly how these ancient sound waves built the modern universe, think of it exactly like throwing a heavy stone into a shallow, muddy pond. The moment the stone hits the water, it creates a powerful acoustic ripple that travels outward in a rapidly expanding perfect circle. As that ripple moves across the pond, it physically pushes the mud, sand, and sediment along with it, gradually creating a dense ring of material at the leading edge of the wave. Now, imagine that the ripple is still traveling outward, expanding beautifully across the surface of the water. Suddenly, a flash freeze drops the temperature to absolute zero and instantly freezes the entire pond solid. The moving wave stops dead in its tracks. The mud and sediment are permanently locked into place, forming a physical circular ridge perfectly frozen in the ice, capturing the exact shape of the ripple at the exact moment the freeze occurred. That is precisely what happened on a mind-boggling cosmic scale during the epoch of recombination. The massive sound waves were the ripples, pushing the raw baryonic matter of the universe outward in enormous expanding spheres. And when the universe suddenly cooled down to 3000 Kelvin, allowing the trapped light to finally escape, the cosmic pond instantly froze. The acoustic pressure disappeared, the waves were stopped dead in their tracks, and the dense rings of matter they were pushing were permanently locked into the expanding structure of space. The cold blue spots we see mapped in the ancient light today are simply the frozen crests of those primordial sound waves, perfectly preserved across eternity. It defies all conventional logic and feels completely impossible, but the largest physical structures in the entire universe were built by microscopic whispers of sound. So what exactly happens when we try to measure our own physical motion against this frozen wall of ancient sound? You might remember that earlier, we talked about how you're currently being hurled through the cosmos at a terrifying speed without even feeling a breeze. The cosmic microwave background is the ultimate universe-wide speedometer that allows us to definitively prove it. Because the primordial radiation uniformly fills the entire observable universe, it acts as an absolute rest frame, a stationary cosmic backdrop against which all local movement can be accurately measured. When astrophysicists first mapped the temperature of the sky with high precision, they noticed something incredibly strange that had absolutely nothing to do with the Big Bang itself. One entire half of the night sky was slightly warmer, and the exact opposite half of the sky was slightly cooler. In physics, this massive temperature imbalance is called the cosmic dipole. It happens because our entire solar system, actively dragged along by the immense gravity of the Milky Way galaxy, is plunging through the universe at roughly 370 kilometers per second toward the constellation Leo. As we speed rapidly in that direction, we are physically crashing into the ancient photons, compressing their wavelengths and making them appear slightly hotter and bluer through the Doppler effect. On the exact opposite side of the sky, we are speeding away from the photons, stretching them out and making them appear slightly colder and redder. You're not sitting still. You're actively surfing on a massive invisible wave of ancient light. But exactly how far away is this glowing wall that we are crashing into? If the light has been traveling for 13.8 billion years, you might logically assume that the edge of the universe is exactly 13.8 billion light-years away. But logic breaks down when you factor in the relentless expansion of space. So, while those ancient photons were desperately flying toward our telescopes, the very fabric of the void they were traveling through was stretching out beneath them. The starting line has been rapidly moving away from the finish line for all of eternity. Because of this extreme cosmic stretching, the physical location where that ancient light originally departed from is no longer 13 billion light-years away. Today, it is located an astonishing 46 billion light-years away in every direction. This creates an observational bubble with a massive diameter of 92 billion light-years. The cosmic microwave background is the literal physical edge of this bubble. It is the absolute limit of the observable universe. We are trapped inside a massive sphere of visibility, and that freezing microwave wall is the impenetrable shell, and that immense spherical shell is incredibly complex. The ancient light raining down on our planet every single second isn't just carrying simple temperature data, it is actually carrying a distinct measurable physical geometry. In the final chaotic moments before the fog cleared, as the ancient photons violently ricocheted off the very last free electrons during the epoch of recombination, they became polarized. This means that the electromagnetic waves were forced to vibrate in specific, aligned orientations based on how they bounced. By meticulously mapping these delicate polarization patterns across the sky, modern astrophysicists can literally see the microscopic directional movements of the primordial plasma in the exact moment before the universe froze. We are not just looking at a flat, static photograph of the ancient fire, we are actively reading the precise mechanical stresses, the acoustic pressures, and the chaotic gravitational currents of a superheated universe just milliseconds before it turned transparent. This ancient light is so deeply, physically woven into the modern fabric of reality that it has actually interacted with human technology on a daily basis for decades without anyone realizing it. To understand how pervasive it is, think of an old, bulky analog television set sitting in a living room in the 1990s. When you turned the heavy plastic dial between active broadcast channels, the glass screen would instantly fill with chaotic black and white static, accompanied by a loud, aggressive hissing noise. Most people naturally assumed that the static was just random, meaningless electrical interference from nearby appliances, a passing car engine, or local radio towers. But about 1% of that static was not local interference at all. 1% of that chaotic, flickering hiss was the television antenna physically intercepting the stretched-out freezing photons from the cosmic microwave background. Millions of tiny, invisible packets of energy that have been traveling through the freezing void for 13.8 billion years finally ended their epic journey by crashing directly into the circuitry of a household television. Every time you stared at an untuned analog screen, you were unknowingly watching the direct physical embers of the Big Bang crackling in your own living room. But this intimate physical connection with the dawn of time will not last forever. The universe is still expanding, and we now know that this expansion is actually accelerating, driven outward by the mysterious, invisible force we call dark energy. As the very fabric of space stretches faster and faster, the cosmic microwave background is being pulled further and further into the red side of the electromagnetic spectrum. Today, the ancient light conveniently sits in the microwave spectrum where it is easily detectable by our specialized scientific satellites and even old analog televisions. But as trillions of years slowly pass, the relentless expansion of the void will violently stretch those wavelengths until they turn into incredibly long, incredibly weak radio waves. Eventually, the physical energy of those ancient photons will drop so low that they will become completely undetectable by any technology. The glowing wall of the primordial plasma will fade into absolute inescapable darkness. Any future civilizations that might evolve in our galaxy trillions of years from now will look up into a pitch-black silent void. They will have no physical evidence whatsoever that the Big Bang ever happened, no ancient light to measure, and no cosmic background to prove that the universe had a fiery beginning. Based on all available evidence, they will falsely believe that the universe is entirely static, eternal, and empty. We are incredibly privileged to live in the exact cosmic era where the edge of time is still brightly visible, but this perfectly understood cosmic anatomy hides a massive, deeply unsettling contradiction. When we try to trace this ancient light all the way back to the very beginning, the rules of physics violently break down. To understand why this perfectly uniform temperature is a complete disaster for modern astrophysics, we first have to look at the simple, everyday mechanics of how heat actually travels. Think about the basic thermodynamics operating inside your own home. If you pour a boiling cup of coffee and place it on a table in a freezing cold room, what happens? The coffee doesn't stay boiling forever, and the room doesn't stay freezing. The heat from the liquid slowly radiates outward, colliding with the cold air molecules, transferring energy until the coffee and the room eventually reach the exact same temperature. This is thermal equilibrium. But the most crucial part of this process is that it takes physical time. Heat cannot teleport. The warm molecules must physically interact with the cold molecules. If the room is incredibly large, it will take a much longer time for the temperature to equalize. This fundamental rule applies to everything from a cup of coffee to the primordial plasma of the Big Bang. Now, let us scale that simple, intuitive thermodynamic rule up to the absolute limits of the observable universe. And we already know that the cosmic microwave background represents the outer boundary of a massive observational bubble. If you point a highly sensitive radio telescope toward the deepest part of the northern sky, you're looking at ancient light that was originally emitted 46 billion light-years away from our current position. That specific distant patch of primordial plasma has an exact verified temperature of 2.725 Kelvin. Now turn your telescope completely around and point it toward the deepest part of the southern sky, looking at the exact opposite side of the universe. That light was also emitted 46 billion light-years away, in the complete and total opposite direction. When you carefully measure the temperature of that second patch of plasma, you find something that defies all rational expectations. It is also exactly 2.725 Kelvin. This might sound like a beautiful, elegant cosmic harmony, but to a theoretical physicist, it is an absolute mathematical nightmare. The physical distance between that northern patch of plasma and that southern patch of plasma is roughly 92 billion light-years. They're separated by the widest possible gulf in all of physical reality. Yet somehow, against all conventional logic, they have reached a state of perfect, flawless thermal equilibrium. They share the exact same temperature down to the 5th decimal point, matching each other with a precision that seems entirely impossible for a chaotic, expanding universe. Why is this such a devastating problem? Because of the absolute, unbreakable speed limit of the universe, the speed of light. Nothing, not even information or raw heat, can travel faster than a photon. For two vastly separated regions of space to reach the exact same temperature, they must be able to physically interact. The hotter region must have enough time to send its thermal energy across the void to warm up the colder region, just like the coffee warming the room. But the universe is only 13.8 billion years old. And the physical distance between the two opposite edges of the cosmic microwave background is 92 billion light-years. Imagine a beam of light travelling from the left side of the universe to the right side since the very first fraction of a second of the Big Bang. It would have only crossed a tiny fraction of that enormous distance. It is physically impossible for the left side of the universe to have ever communicated with the right side. They have never touched. They have never exchanged heat. They are completely and utterly isolated from each other by the inescapable barrier of time and the ultimate speed limit of light. To put the sheer absurdity of this into perspective, imagine that you brew a fresh, boiling cup of coffee in a kitchen in New York City. At the exact same second, someone else brews a completely different cup of coffee in a sealed kitchen in Tokyo. The two cups are trapped in their respective rooms, completely isolated from the outside world, with absolutely no way of interacting, communicating, or sharing the same atmospheric air. 10 hours later, you measure the temperature of the coffee in New York, and it is exactly 21.345 degrees Celsius. Then, you measure the temperature of the coffee in Tokyo, and it is also exactly 21.345 degrees Celsius. It is entirely impossible for the New York Cup to have equalized its heat with the Tokyo Cup. The geographical distance is simply too great, and the physical isolation is too absolute. If you found that terrifying level of identical precision in two completely disconnected thermodynamic systems, you would immediately assume that the experiment was rigged, or that some invisible, magical force had perfectly synchronized them before they were geographically separated. In the cold, hard realm of cosmology, scientists do not believe in magic, but the entire night sky is completely filled with billions of these identical cups of coffee, all sitting at precisely 2.725 Kelvin, despite being separated by tens of billions of light-years of empty space. This horrific, unsolvable contradiction is formally known in astrophysics as the horizon problem, and for a very long time it completely broke the standard model of the Big Bang. It induced a profound, lingering sense of despair and intellectual paralysis within the global astrophysical community. The most brilliant, highly educated minds on the planet were backed into a terrifying corner, staring helplessly at a universe that blatantly violated its own fundamental physical laws. The standard established theory of the Big Bang was incredibly successful at explaining how the universe expanded, how the elements were forged, and how the ancient light eventually cooled. But it completely, utterly failed to explain why the cosmos was so perfectly uniformly balanced. The math implied that the temperature of the entire universe was simply born perfect across billions of light-years simultaneously. It suggested an arbitrary, unscientific miracle that required no logical mechanism or physical explanation. For a dedicated theoretical physicist, relying on an unexplained miracle is exactly equivalent to admitting total, humiliating defeat. It meant that our fundamental foundational understanding of space, time, and the very origin of reality was catastrophically flawed at its core. We were essentially blind, completely trapped in a cosmos that made absolutely no logical sense, staring at a frozen wall of light that was loudly mocking our ignorance. Don't assume this is just an abstract academic problem. This terrifying contradiction threatens the very foundation of how you understand reality. That terrifying contradiction only makes sense once you understand the absolute unimaginable violence of the very first fraction of a second of creation. But before the scientific community could even attempt to solve the horizon problem, they realized that the situation was actually much worse than they initially thought. The universe was not just suffering from a temperature paradox, it was suffering from a geometric paradox as well. When astrophysicists measured the overall shape and density of the cosmos, they found that it was perfectly, flawlessly flat. In cosmology, a flat universe means that the density of matter and energy is balanced on an absolute knife edge, a critical threshold known as omega equals 1. If the early universe had been even a tiny fraction of a percent denser, the gravitational pull would have caused everything to immediately collapse back in on itself in a big crunch. If it had been a tiny fraction of a percent less dense, the universe would have expanded so rapidly that galaxies and stars could never have formed. Yet, our universe is perfectly balanced, exactly on the line between life and death. This is known as the flatness problem. Combined with the horizon problem, it seemed as though the entire cosmos was a mathematically rigged game, an impossible structure that simply could not exist naturally. The intense intellectual despair that gripped the astrophysical community finally broke in late 1979, thanks to a young, relatively unknown theoretical physicist named Alan Guth. Working late into the night at the Stanford Linear Accelerator Center, Guth was not actually trying to solve the grand, sweeping mysteries of cosmology. He was primarily studying the complex quantum behavior of subatomic particles. But as he meticulously manipulated his complex thermodynamic equations, desperately trying to understand the state of matter at the absolute extremes of heat, he stumbled upon a breathtaking mathematical mechanism that would permanently rewrite human history. Guth proposed a radical, aggressive, and highly controversial addition to the standard Big Bang theory. He called his brilliant new concept cosmic inflation. According to his mathematics, this happened at exactly 10 to the minus 36 seconds after the moment of creation. This time frame is so impossibly short that human brains cannot even truly comprehend it. During this brief window, the young universe underwent a violently exponential period of hyperexpansion. For a fraction of a heartbeat, the fundamental fabric of space itself was driven outward by a repulsive anti-gravitational force. This caused the physical volume of the universe to expand at a rate far faster than the speed of light. In less time than it takes a single photon to cross the microscopic nucleus of a hydrogen atom, a tiny submicroscopic patch of space was violently stretched to macroscopic proportions. The universe expanded by a staggering factor of at least 10 to the 26th power, growing from something a billion times smaller than a proton to the size of a grapefruit in an unimaginably small fraction of a microsecond. This concept of hyperexpansion was completely revolutionary because it instantly and elegantly solved the catastrophic horizon problem. Think back to our terrifying analogy of the two completely identical cups of coffee sitting in isolated rooms in New York and Tokyo. The only logical way those two cups could possibly share the exact same temperature is if they were originally brewed in the exact same coffee pot. They must have reached thermal equilibrium together in the exact same kitchen. Only then could they be suddenly transported to opposite sides of the planet. Cosmic inflation provides exactly that mechanism. The left side of the observable universe and the right side of the observable universe are not strangers. Before the violent epoch of inflation began, those two widely separated patches of space were actually sitting right next to each other. They were physically touching, intimately connected within a submicroscopic, ultra-dense pocket of the primordial plasma. Because they were so incredibly close together, there was plenty of time for their heat to perfectly equalize and share the exact same temperature. Then, inflation kicked in. The repulsive force of space itself suddenly grabbed those two identical patches of plasma and violently ripped them apart. It dragged them across the void at speeds far exceeding the speed of light. They were eventually placed 92 billion light-years away from each other. They share the exact same temperature today not because they communicated across the vast cosmic void, but because they used to be the exact same microscopic neighborhood before space itself tore them apart. The miracle was finally explained, and in a beautiful, highly satisfying stroke of theoretical elegance, cosmic inflation also perfectly solved the terrifying flatness problem. Guth's concept of hyperexpansion explains exactly why the geometry of our modern universe appears so flawlessly balanced on a gravitational knife edge. To visualize how this works, imagine that you are holding a completely uninflated, highly wrinkled and crumpled rubber balloon in your hands. If you blow a tiny bit of air into it, the surface remains highly curved, completely full of chaotic valleys, ridges and complex topology. But what if you were somehow able to hook that balloon up to an industrial compressor? Imagine instantly inflating that exact same piece of rubber to the massive, staggering size of the planet Earth. What would the surface look like to a tiny ant walking across it? It would look perfectly, totally flat in every single direction. Cosmic inflation did exactly this to the physical fabric of space. The violent, exponential stretching of the early universe took whatever chaotic, crumpled, tangled geometry existed at the exact moment of creation and forcefully ironed it out. It stretched the fundamental curvature of space so dramatically and so quickly that from our incredibly limited microscopic perspective inside the cosmos today, it appears mathematically flat. The universe isn't a rigged game, and it wasn't born from a magical miracle. It was simply stretched into geometric perfection by the overwhelming brute force of its own explosive birth. With the triumph of cosmic inflation, we finally arrive at the profound, satisfying answer to the ultimate question that started this entire journey. We open this investigation by asking what exactly lies at the edge of the universe, and why we cannot simply look past the glowing wall of the cosmic microwave background to see what is on the other side. We now know, with absolute scientific certainty, that the microwave background is not a physical brick wall at the end of reality. Yep, it is simply a horizon of time. It is the absolute unbreakable limit of how far light has been able to successfully travel through the expanding void in exactly 13.8 billion years. But because of the staggering implications of Alan Guth's hyperexpansion, we also know that the observable universe, that massive 92 billion light-year sphere of visibility that we are currently trapped inside, is absolutely not the entire universe. It is just a tiny, incredibly localized bubble in an ocean of existence. The true universe, the physical space that actually exists beyond the glowing microwave radiation, was stretched so violently during the epoch of inflation that it extends far, far beyond our cosmic horizon. There is no physical edge where space suddenly stops. There is no terrifying cliff at the end of reality where matter ceases to exist. If you were somehow able to magically teleport 46 billion light-years away, standing exactly on the glowing boundary of our observable universe, you would not see a wall. You would not find an end. You would simply find yourself standing squarely in the center of your very own massive bubble, surrounded by billions of brand new galaxies. Looking all the way back, our Milky Way would appear as just another distant, fading smudge of ancient light. The true universe is unimaginably vast, perhaps even completely infinite, completely dwarfing the tiny illuminated pocket we happen to call home. We can never see past the edge, not because there is nothing out there, but because the light from those infinite realms simply hasn't had enough time to reach our telescopes yet. The grand paradox is finally resolved. The cosmic boundary is an illusion of light, a trick of time, not a physical boundary of space. If this elegant mathematical solution explains the violent origin of the cosmos so perfectly, what does it definitively tell us about the ultimate fate of reality? Or that terrifying answer only makes sense once you finally accept the ultimate inescapable triumph of nothingness. For a very long time, astrophysicists firmly believed that the gravitational pull of all the matter in the universe would eventually act like a massive set of cosmic brakes. They logically assumed that the violent, explosive expansion triggered by the Big Bang and cosmic inflation would gradually slow down over billions of years, exhausted by the sheer, crushing weight of its own mass. In the late 1990s, two independent teams of astronomers set out to measure exactly how much the universe was slowing down by observing distant, exploding stars known as supernovas. But when they finally looked deep into the void and analyzed the data, they found the exact opposite of what everyone expected. The expansion of the universe is not slowing down at all. It is actively speeding up. Some mysterious, totally invisible, and deeply poorly understood force is actively pushing the fundamental fabric of space apart at an accelerating rate. Scientists formally call this terrifying phenomenon dark energy, and it currently makes up roughly 68% of everything that exists in the entire universe. Dark energy is not a physical substance you can easily touch, capture, or measure directly in a laboratory. It appears to be an inherent, built-in property of space itself. As the universe expands, more empty space is created, which inevitably means there is more dark energy, which pushes the universe apart even faster in a runaway, catastrophic feedback loop. This accelerating expansion fundamentally dictates the ultimate tragic fate of our reality. The universe will not end in a spectacular, fiery big crunch where everything collapses back together. It will end in a relentless, freezing, and agonizingly slow dilution of all physical matter and energy, a bleak scenario formerly known as the Big Freeze or heat death. The story of the universe is not a story of eternal life and endless rebirth. It is a long, slow, unavoidable march toward absolute, inescapable oblivion. To truly understand the chilling melancholy of this distant future, you have to imagine exactly what the night sky will look like billions of years from now. Right now, when you look through a powerful telescope, the universe appears incredibly crowded, teeming with billions of swirling galaxies, glittering clusters, and massive, interconnected superstructures that stretch across the cosmic web. But because of the relentless, accelerating push of dark energy, all of those distant galaxies are currently flying away from us at terrifying speeds. Eventually, as space continues to stretch faster and faster, their recession velocity will physically exceed the speed of light. When that happens, the light they emit will never be able to reach our telescopes again, no matter how sensitive our instruments become. So, they will physically cross the cosmic event horizon, and permanently vanish from our observable reality. Think of it exactly like a massive, majestic fleet of brightly illuminated ships sailing closely together on a pitch-black ocean. Slowly but surely, the relentless expanding currents of the dark water begin to pull the ships apart. One by one, the distant ships drift too far away and slip silently over the physical horizon, their warm guiding lights disappearing into the freezing dark water forever. No matter how hard you look, no matter how powerful your spyglass, you will never see them again. You're entirely cut off, permanently stranded in the dark. This is exactly what will happen to the cosmic web. Within the next 2 trillion years, every single galaxy outside of our immediate local neighborhood will be pushed beyond the horizon of visibility. The universe will effectively become a localized island. The Milky Way will inevitably collide and violently merge with the neighboring Andromeda galaxy to form a single, massive, elliptical supergalaxy. After that merger, we will be surrounded by absolutely nothing but an infinitely expanding pitch-black void. Any future astronomers living on a rocky planet inside this merged supergalaxy will look out into the deep cosmos and see absolutely nothing. There will be no cosmic microwave background left to measure, no distant galactic clusters to photograph, and no expanding universe to study. There will be just an endless, empty, terrifyingly lonely ocean of black space stretching in every direction. But the profound tragedy of the cosmos does not end with mere physical isolation. Even within our own merged, lonely supergalaxy, the vibrant, glowing fires of creation cannot burn forever. Stars are not eternal entities, they are massive, delicate nuclear engines, and like all engines, they require a specific fuel. Right now, the universe is firmly in the stelliferous era, a brief, beautiful, and highly active golden age where massive clouds of primordial hydrogen gas are constantly collapsing under their own gravity to ignite brand new, brilliantly shining stars. But the total supply of hydrogen gas in the universe is strictly finite, and it is steadily, irreversibly running out. Trillions of years from now, the very last free-floating clouds of star-forming gas will be completely exhausted. Or the era of stellar birth will permanently end, and the universe will never create another star. The massive, brilliant blue stars which burn extremely hot and extremely fast will be the first to die, destroying themselves in violent, spectacular supernovas. The smaller yellow stars like our own sun will slowly swell into massive red giants, swallowing their inner planets before violently shedding their outer layers, leaving behind only small, dense, glowing embers known as white dwarfs. Finally, the universe will be left with only red dwarfs, the smallest, dimmest, and most thermodynamically efficient stars in existence. Because they burn their fuel so incredibly slowly, these tiny stars can survive for trillions of years, huddling together in the rapidly deepening dark. But eventually, inevitably, even the very last red dwarf will exhaust its final drops of nuclear fuel. It will quietly flicker, slowly cool down, and quietly fade away into a freezing, completely invisible lump of highly compressed, degenerate matter known as a black dwarf. Think of it like a grand, glittering, technologically advanced metropolis that is slowly, methodically shutting off its city lights, one struggling district at a time, until the entire sprawling civilization is completely swallowed by absolute freezing darkness. The universe will fundamentally transform from a vibrant living ecosystem into a silent, frozen graveyard of stellar corpses, populated only by dead stars, rogue planets, and freezing asteroids wandering aimlessly through the pitch-black void. As we push the cosmic timeline forward into unimaginable, staggering numbers, perhaps 100 trillion years into the dark future, the physical structure of reality becomes incredibly strange, hostile, and completely unrecognizable. With all the stars permanently extinguished and no new light being created, the only objects left in the universe with any significant mass, density, or gravitational influence will be black holes. This bleak transition marks the absolute beginning of the aptly named black hole era. In this unimaginably distant future, the universe will be a profoundly terrifying place, or the sky will be completely devoid of any optical light, a perfectly pitch-black canvas without a single star. The dead, frozen husks of planets and crushed stellar cores will occasionally be thrown completely out of their dead galaxies by random, chaotic gravitational encounters, wandering the infinitely expanding void alone for eternity. Other dead stars will be tragically captured by the intense, inescapable gravitational pull of supermassive black holes lurking in the dark centers of the dead galactic clusters. These silent, invisible monsters will slowly and methodically consume the remaining shattered debris of the cosmos, ripping planets and black dwarfs apart in the dark and growing steadily larger and more massive. Occasionally, over billions of years of silent wandering, two of these supermassive black holes will blindly stumble into each other's gravitational influence. They will engage in a slow, invisible, and terrifying orbital dance, spiraling closer and closer together until they violently collide, sending massive ripples of gravitational waves echoing through the completely empty void. But nobody will be there to hear or record them. For an incredibly long stretch of cosmic time, these merging black holes will be the undisputed, terrifying rulers of reality. They will act as the absolute last bastions of concentrated mass in a universe stretched far too thin to support anything else. The cosmos will be nothing more than an infinitely expanding void of absolute zero, punctuated only by invisible gravitational sinkholes waiting patiently in the endless dark. But incredibly, in the cold, hard, unforgiving mathematics of quantum physics, even the mighty black holes are not truly eternal. Thanks to the groundbreaking theoretical work of the physicist Stephen Hawking, we now know that black holes are not completely black, and they are absolutely not permanent. Hawking proved that empty space is not actually empty. It is constantly boiling with pairs of virtual particles that appear and annihilate each other instantly. But when this happens exactly on the razor-thin boundary of a black hole's event horizon, one particle falls into the abyss. The other particle is forcefully ejected out into space. The black hole is forced to give up a tiny fraction of its own mass to pay for the escaping particle. This means the black hole is slowly bleeding to death. This extremely slow, agonizing process of gravitational decay is formally known as Hawking radiation. Over the course of timescales so astronomically large that they require entirely new branches of advanced mathematics to even write down, even the most massive supermassive black holes will eventually evaporate completely. This mind-boggling time frame is specifically one followed by 100 zeros, formerly known as a googol of years. So, they will slowly leak their enormous mass away into the void, particle by microscopic particle, over unimaginable aeons of silent time. As they gradually lose their mass, they will begin to shrink, becoming hotter and hotter until they finally explode in a brief, blinding flash of high-energy gamma rays. These solitary final explosions will be the very last significant events to ever occur in the physical universe. They will be a sad, brief flicker of intense light, immediately swallowed by the overwhelming endless dark. After the very last black hole evaporates into radiation, the universe will finally reach its ultimate, inescapable thermodynamic destination, the heat death. This is a state of maximum, absolute thermodynamic entropy. All of the physical matter, all of the useful energy, and all of the chaotic creative potential of the Big Bang will have been completely and utterly diluted. The physical temperature of the entire universe will drop to exactly absolute zero, completely uniform across a vast, infinitely expanding, and totally empty void. Because there are no longer any differences in temperature anywhere in the cosmos, and absolutely no concentrated pockets of mass left to manipulate, absolutely no physical work can ever be done again. Energy can no longer move from a hotter region to a colder region, because the concepts of hot and cold simply no longer exist. In this permanently frozen, perfectly diluted state, the concept of time itself essentially loses all physical meaning. Time requires change to be measured, because without change, without movement, and without any physical events occurring, there is absolutely no way to distinguish the past from the future. A single second, a trillion years, and an eternity all become exactly the same thing. The entire cosmos becomes a perfectly smooth, completely featureless ocean of nothingness, completely devoid of structure, light, or meaning. The universe will not collapse back on itself, and it will not be magically reborn. It will simply exist, perfectly dark, perfectly cold, perfectly empty, and perfectly silent forever. The violent, beautiful 13 billion year story of reality will finally end in a perfectly flat mathematical line of absolute nothingness. It defies all conventional logic and feels completely impossible. But to actually see this terrifying future, we had to build the most sensitive machines in human history. To understand how we finally hit the ultimate technological limit of cosmic observation, we have to look back at the heroic engineers who refused to accept the limitations of our own planet. For decades after Arno Penzias and Robert Wilson accidentally discovered the cosmic microwave background, astrophysicists were incredibly frustrated. They knew that the ancient light was out there, silently bathing the Earth in microwave radiation, but they couldn't see the microscopic details they desperately needed to prove cosmic inflation. The problem was our own atmosphere. The Earth is surrounded by a thick, turbulent blanket of water vapor, oxygen, and nitrogen. This atmosphere completely blocks, scatters, and absorbs incoming microwave radiation. Trying to map the delicate temperature variations of the Big Bang from the surface of the Earth was an incredibly difficult task. It was like trying to read the fine print of a distant newspaper while standing at the bottom of a violently churning swimming pool. To see the dawn of time clearly, humanity had to physically leave the planet. The first major, undeniable triumph in this grand orbital campaign came in 1989, when NASA officially launched the Cosmic Background Explorer, famously known in the scientific community as COBE. Finally escaping the murky, interfering atmosphere of Earth, COBE spent several years orbiting our planet, slowly and methodically scanning the deep cosmos. It was the very first scientific instrument to successfully detect the microscopic anisotropies, those crucial, incredibly faint red and blue spots of varying density trapped in the ancient plasma. When the lead mission scientist finally released the very first blurry, heavily pixelated maps of the early universe to the public, the emotional impact was absolutely staggering. The lead researcher, George Smoot, famously declared to the global press that if you were a religious person, looking at the COBE data was exactly like looking at the face of God. It was the first time humanity had ever seen the physical seeds of reality. A little over a decade later, in 2001, NASA pushed the boundary even further and launched the Wilkinson Microwave Anisotropy Probe, widely known as WMAP. Thus, WMAP provided a massive revolutionary leap in technological capability, delivering an incredibly sharp, highly detailed, and mathematically rigorous map of the cosmic microwave background. It was WMAP that finally and definitively proved that the universe is exactly 13.8 billion years old, putting an end to decades of fierce cosmological debate. It also provided the exact terrifying recipe of our physical reality. It proved once and for all that normal baryonic matter accounts for less than 5% of the entire universe. This is the physical stuff that actually makes up you, me, the Earth, and the shining stars. The vast, overwhelming majority of reality is completely dominated by invisible dark matter and the mysterious, repulsive force of dark energy. But the true, crowning achievement of cosmic cartography arrived in 2009 when the European Space Agency launched the formidable Planck satellite. Planck was a marvel of modern engineering, an instrument so incredibly sensitive and so flawlessly designed that it represents the absolute pinnacle of human observation. To measure the incredibly faint, freezing whispers of the cosmic microwave background without any interference from its own internal heat, the detectors inside Planck had to be cooled to just a fraction of a degree above absolute zero. It was, for a brief period, the coldest known object in the entire universe, a perfectly frozen mechanical eye staring deep into the ancient past. The data returned by Planck was nothing short of revolutionary. It mapped the entire sky in unprecedented, breathtaking high resolution, capturing the primordial sound waves and the microscopic anisotropies with a level of precision that border on the miraculous. When you look at the Planck map of the cosmic microwave background, you're looking at one of the most important scientific images ever produced by the human race. It is the definitive, ultimate baby picture of the universe, capturing the exact structural layout of reality just 380,000 years after creation. Every single galaxy, every single supercluster, and every single void that exists in the modern universe was accurately predicted by the microscopic density variations mapped by the Planck satellite. The sheer technological complexity required to capture this ancient light cannot be overstated. When astrophysicists study the cosmic microwave background, they aren't just taking simple photographs. They're utilizing incredibly advanced techniques like deep space photometry to measure the absolute intensity of the light, and high-resolution spectroscopy to analyze the exact distribution of energy across the electromagnetic spectrum. By studying the precise spectrum of the incoming radiation, scientists can definitively prove that it perfectly matches the theoretical profile of a black body, completely confirming the thermal history of the Big Bang. While the Planck satellite was busy mapping the invisible microwave boundary of the universe, other legendary instruments were working to confirm exactly how those ancient seeds blossomed into the massive structures we see today. The iconic Hubble Space Telescope spent decades staring into tiny, seemingly empty patches of the dark sky, conducting the famous deep field observations. By leaving its shutter open for hundreds of hours at a time, Hubble collected enough faint ancient photons to reveal tens of thousands of mature galaxies hiding in the dark. This definitively proved that the universe is incredibly vast and densely populated. And today, we have pushed the boundary of human sight even further with the launch of the James Webb Space Telescope. Operating 1,000,000 miles away from Earth, cloaked in the freezing shadow of its massive sunshield, the James Webb Telescope is specifically designed to hunt for the very first stars and galaxies that ever formed. It is looking back through time, searching the deep infrared spectrum to find the exact moment when the dark ages of the universe finally ended and the first massive stars ignited to illuminate the cosmos. Furthermore, measuring the extreme redshift of the most distant galaxies allows us to accurately track the accelerating expansion of the universe over billions of years. When the James Webb Telescope peers into the dark, it relies heavily on analyzing this cosmological redshift. As the light from the very first galaxies travels toward Earth, the physical expansion of space aggressively stretches its wavelength, shifting it completely out of the visible spectrum and deep into the infrared. James Webb was specifically painstakingly engineered with revolutionary gold-coated beryllium mirrors and hyper-cooled infrared sensors to capture this incredibly faint, heavily redshifted light. Every single image it produces is a stunning technological miracle, the result of decades of relentless international collaboration, brilliant theoretical engineering, and an absolute refusal to accept the natural limits of human vision. Between the microwave maps of Planck and the deep infrared vision of James Webb, humanity has successfully bridged the gap between the blazing plasma of the Big Bang and the complex, beautiful universe we inhabit today. When you take a step back and truly and deeply consider what we have miraculously accomplished over the last century, it should fill you with a profound, overwhelming sense of pride and immense existential awe. We are a remarkably young, incredibly fragile species. We evolved on a small, rocky, relatively insignificant planet orbiting a completely average yellow star, tucked away on the quiet, dusty outer edge of a standard spiral galaxy. We are physically bound by gravity to the thin surface crust of this wet rock, completely isolated from the rest of the cosmos by unimaginable, hostile gulfs of freezing, empty space. And yet, we have managed to peer past the veil of time itself, using absolutely nothing but the raw, creative power of the human mind. We relied on the elegant language of mathematics and the sheer, stubborn will to understand our place in the dark. We have built incredibly delicate, unimaginably complex machines, capable of surviving the harshest environments conceivable. We have strapped these fragile, multi-billion-dollar mirrors and freezing electronic sensors to the top of massive, highly explosive chemical rockets. We hurled them violently into the hostile, freezing, irradiated vacuum of space, commanding them to read the invisible fingerprints of creation. we have successfully decoded the ancient silent stretched-out whispers of the Big Bang. We have meticulously measured the exact age, the precise geometry, and the fundamental composition of reality itself. We are not just passive observers in this universe, we are quite literally the universe waking up, opening its mechanical eyes, and finally understanding its own violent, magnificent origin. In the grand 13-billion-year history of the cosmos, the simple fact that human beings exist and possess the brilliant, relentless capacity to comprehend it all is an absolute, undeniable triumph of existence. Don't assume this is just an abstract academic problem. This flawless cosmic map hides a terrifying secret that threatens to completely destroy modern physics. So what exactly happens when we push our incredibly flawless cosmic map to its absolute mathematical breaking point? Despite all of our staggering technological achievements and our miraculously precise satellite data, the scientific community is currently terrified, completely locked in a profound state of existential dread. We have mapped the edge of reality, but in doing so, we have uncovered a massive, gaping hole in the very foundation of modern physics. It is formally known as the Hubble tension, and it threatens to tear down everything we thought we knew about the cosmos. To understand this terrifying problem, you have to look at how astrophysicists use the Planck satellite's perfect baby picture of the cosmic microwave background to calculate exactly how fast the universe should be expanding today. They get a very specific, mathematically undeniable number. But when they use the Hubble Space Telescope to measure the actual physical expansion of the modern universe by looking at nearby exploding stars, they get a completely different, noticeably faster number. The two measurements, which represent the absolute pinnacle of human observation, flatly contradict each other. The universe is expanding significantly faster than the ancient light says it should be. This is not a simple rounding error or a minor calibration mistake. It strongly implies that there is a fundamentally unknown physics at play, a hidden dark mechanism tearing the cosmos apart in a way that our current equations simply cannot comprehend. Some theorists believe that dark energy itself might be aggressively evolving, changing its physical properties over time, and violently pushing the cosmic web apart much faster than it did in the ancient past. Others fear that we might need an entirely new law of gravity to explain the discrepancy. Whatever the ultimate answer is, the Hubble tension proves that our highly celebrated map of reality is fundamentally incomplete, and the universe still hides massive, potentially paradigm-shifting secrets. But the Hubble tension is not the only terrifying ghost haunting the halls of astrophysics. While Alan Guth's elegant theory of cosmic inflation perfectly solves the horizon problem and the flatness problem, it introduces an entirely new, deeply uncomfortable mystery. We know that the universe underwent a violent exponential hyperexpansion at the very dawn of time, but we have absolutely no idea what actually caused it. What specific physical mechanism ignited the inflation? What turned on the anti-gravitational repulsive force, and more importantly, what eventually turned it off, allowing normal matter and light to form? Physicists have proposed a hypothetical energy field called the inflaton field to explain the math, but this field has never been observed in a laboratory. It remains a mathematical phantom, a desperate placeholder for our profound ignorance. We know with absolute certainty that the Big Bang happened, and we know exactly how the universe behaved just fractions of a second after it was born. But the exact spark that lit the massive cosmic fire remains completely hidden in the impenetrable dark. And then there is the final, most deeply disturbing open question in all of cosmology. The mathematics of cosmic inflation hold a very dark, extremely controversial secret. The complex equation strongly suggests that once the hyperexpansion of space begins, it becomes mathematically impossible to permanently stop. According to a widely accepted theoretical framework known as eternal inflation, the violent stretching of space didn't just happen once. It is happening constantly, forever, aggressively expanding the true underlying fabric of reality at speeds far beyond the speed of light. Think of the true, absolute reality like a massive, infinitely large pot of violently boiling water sitting on a hot stove. As the water furiously boils, tiny pockets of gas rapidly expand to form individual spherical bubbles that rise to the surface. In this terrifying cosmic analogy, the boiling water is the eternally expanding background of reality. Our entire observable universe, with its 92 billion light-years of space and billions of galaxies, is just a single, microscopic bubble. According to this theory, the Big Bang was not the definitive start of everything. It was simply the exact moment our specific local bubble happened to pop into existence. There are likely billions, perhaps even an infinite number, of other separate bubble universes constantly being born, expanding and dying within the boiling eternal ocean of the multiverse. We are completely trapped inside our own isolated bubble, unable to see, touch, or communicate with the infinite fractal of realities that might exist just beyond our glowing microwave horizon. If you think you finally have a solid, comfortable grasp on this beautiful, terrifying physical reality, you're completely unprepared for the ultimate philosophical truth. To understand why this terrifying physical reality is actually deeply beautiful, you have to look closely at the incredibly fragile nature of human consciousness. When confronted with the true, staggering scale of the cosmos, it is incredibly easy to feel completely paralyzed by existential dread. We are currently trapped inside a microscopic bubble of observable space that is 92 billion light-years across. We know with absolute certainty that the vast expanding cosmic web is slowly tearing itself apart, marching inevitably toward the freezing, silent oblivion of the heat death. In the face of a 100 trillion year timeline filled with dead stars, evaporating black holes, and an eternity of absolute nothingness, a single human life can easily feel entirely meaningless. This is especially true for a fleeting 80 years on a tiny wet rocky planet. We are bound to the surface of a dust mote suspended in a sunbeam, completely surrounded by a dark predatory vacuum that would instantly boil our blood. It feels like a pathetic microscopic rounding error in the grand, uncaring mathematics of reality. But that profound sense of insignificance is based on a fundamental philosophical illusion. The terrifying void out there is not entirely separate from the life down here. You're not some fragile, isolated alien entity that was accidentally dropped into a hostile, uncaring universe. You are a direct biological product of the universe's most violent and spectacular processes. Every single atom of iron flowing through the blood in your veins was violently forged in the crushing nuclear furnace of a dying star billions of years ago. The exact same is true for every molecule of calcium fortifying your bones, and every ounce of carbon that makes up your cellular structure. Those massive ancient stars had to completely exhaust their nuclear fuel, collapse under their own crushing gravity, and detonate in spectacular, blinding supernovas just to scatter the fundamental building blocks of your body across the empty void. You're quite literally made of dead stars. You are the recycled ashes of the early universe, miraculously reassembled by billions of years of biological evolution into a highly complex breathing, thinking machine. The fact that this miraculous biological machinery cannot last forever does not rob it of its meaning. It is precisely what gives it value. In the cold, hard science of economics, value is dictated entirely by scarcity. In a multiverse that is infinitely large, endlessly expanding and overwhelmingly dominated by freezing dark matter, empty vacuums and dead radiation, conscious life is the absolute rarest phenomenon in existence. A diamond is incredibly valuable because it is rare, but human consciousness is infinitely more valuable because it is strictly temporary. A grand, beautiful story only possesses meaning and emotional weight precisely because it eventually comes to a definitive end. So, the ultimate freezing doom of the cosmic heat death guarantees that our brilliant, shining era of starlight and life is a brief, highly exclusive golden age. If we were completely immortal, and if the universe were destined to remain warm and vibrant for all of absolute eternity, then our actions, our love, our art, and our scientific discoveries would lose their immediate, desperate significance. We are incredibly privileged just to be alive right now, exactly at the perfect cosmic moment, when the universe is warm enough to support biology, but old enough to have formed complex chemistry. The skies are not yet completely dark, and the distant galaxies have not yet slipped over the cosmic event horizon. So, we sit precisely on the razor-thin edge of eternity, equipped with the technology to peer deep into the ancient dark and decode the fundamental secrets of our own violent origin. We finally understand what the boundary of our reality actually is, and why looking past it is physically impossible. We are not just a collection of random, meaningless atoms shivering in the dark. We are the universe experiencing itself. We are the cosmos waking up, opening its eyes, and marveling at its own magnificent, terrifying reflection in the mirror of time. We've covered a lot today. We stared into the ancient plasma of the Big Bang, watched the universe stretch itself flat, and faced the terrifying reality of a cold, endless doom. The edge of the universe is not a physical brick wall, it is simply a boundary of time and light, hiding an infinite, eternally boiling multiverse just out of sight. But the grand story of our cosmos doesn't stop here. While we have mapped the edge of reality, there are completely different, heavily localized nightmares waiting for us right next door. If you want to know why living on the moon is actually much worse than you think, make sure to subscribe and turn on notifications so you don't miss the next video. Until then, keep looking up,